0.24 comes out of the integral dx over 0.12 minus 12x squared. Okay? And what are the limits of the integral? X goes from 0 to 0.05. Now, actually, over here, I need an E0, right? My permittivity of space. E0, E0. And then I need a E0, E0, E0. And then when I reciprocate it, I need an extra E0 here, E0. Okay? So now I'm going to integrate this. Integral of 1 divided by parentheses 0.12 minus 12x squared, okay, comma, then you go x, comma, 0, comma, so you're putting all of this under the fn int function, x, 0, and then a 0.05. Okay, let's see what we get. We get 0.45, 0.457755. Then you multiply that by 0.24. And then you multiply by E0. E0 is 8.85 times 10 to the minus 12. So multiply this by 8.85. You get 0.97. And then 10 to the minus 12 is a pico. So we can say our final answer for 0.97 picofarads. Now I can answer any other kinds of questions about this capacitor. I can say, what's the potential energy stored in it? What's the charge on either plate? And then I could do other stuff. And you could look at the other problems that I've solved in this section, in this chapter, to see what, how you would go about this. Now, what would have happened if we had switched the dielectrics? If we put the top dielectric 4, bottom dielectric 3, is the answer symmetrical? Well, in this case, it looks like there would be more of the 4. The volume of the top is more than the volume of the bottom. So it looks like the top would win, more volume, and if it's 4, it should probably be bigger, the capacitance. So what would change here? This would stay 0.03 minus 4. This would stay, this would change to 4. Okay, let's do this in a different color here. This would change to 4. This would change to 3. Then this would change to 4. This would change to 3. When you cross multiply, you would get 0.09 minus 3y plus 4y over 12. This number would stay the same. But over here, you would end up getting 0.09 plus y. Then that would reciprocate. You get 0.09 plus y, and then you get 0.09 plus y would still be equal to 12x squared. Okay? And then you would still integrate from 0 to 0.5. So let's see what would that come out. You would go, again, you go to calculus, fn int, 1 divided by 0.09 plus 12x squared, comma x, comma 0, comma 0.05, times 0.24 times 8.85. I'm getting 1.07. 1.07 picofarads. So if I made the bigger dielectric, the top one, you get a bigger capacitance. The problem could even say, by what ratio will the capacitance rise when you switch the dielectrics? So you can just take the ratio 1.07 over 0.97, and then you get something like by 1.10. So by 10%, the capacitance would rise by a factor of 10% when you switch the dielectrics. You can add more stuff to this problem too. You could say something like this. How would you get the capacitance of this kind of capacitor? What if you had something looking like that? So this part is 4, this part is 3, but then this part is straight. Well, then what you have to do with this kind is you would have to split this up into 3 capacitors. One, split it down this one. You have 3 and a 4, right? So you would do exactly what I just did with the 3 and the 4, and depending on the dimensions of the capacitor, do exactly what I did. So then you would end up having 3 capacitors here. It's like having a capacitor there, and then another capacitor here. Next to it, another capacitor that's parallel to them. Okay? So together is already comprising one of them, right? So whatever I just did with this, you would do with these two. Then you would find the capacitance of this single one, which is easy to do. There's no integration involved. So you just do kappa A E0 over D using the area of this. So just calculate the capacitance of this one and then simply add them because they're in parallel, right? So let's say you found the capacitance of this to be 2 picofarads for the sake of argument, just this portion. Then you would add that to this, depending on what you got. If you got 1 picofarad, let's say, for this one, 2 plus 1, you would get 3. So you would simply just add them. It would be a combination of 2 capacitors and another capacitor. So this is a pretty good example to show how to do multiple capacitors, and even if the distance is varying with some weird function. Thank you.